Hello, everybody. The Republic of Singapore's Air Force released their final update on the F-16 mishap that happened actually not too long ago, which is pretty fast, especially when you compare it to the way we do things here in the U.S. But not a lot of details like you'd see in an AIB report, but the final report does show what happened and why, and it's kind of a once-in-a-lifetime event. It's something that they had not seen before. So we'll go through their final report, break it down, and see what we can learn.
3, 2, 1, flight off.
All right, this is from the Singapore government's official website. Their Air Force, it's the final update of the RSAF's F-16 crash that happened not too long ago, 8 May. So this is incredibly fast. It's July right now. I mean, you're considering we're getting AIB reports from last year now with the Air Force side, and the Navy doesn't even share them anymore. All right, so the investigation on the Republic of Singapore Air Force F-16 crash at Tengah Air Base on 8 May 2024 is concluded. It was led by the RSAF, supported by Lockheed Martin and the Transportation Investigation Bureau. During the investigation, data downloaded from the flight data recorder and digital flight control computer of the incident F-16 were reviewed. They also talked to the pilot and maintainers, maintenance records, and everything. So basically what happened, pilot experienced a malfunction of his digital flight control system during takeoff. Now, well, you'll hear the term FLICUS, which is the flight control system. It's the flight control computer. The F-16 Block 40 and above has a digital flight control computer, and the previous blocks had analog, which from a pilot's perspective is just changes a couple switches, really. It wasn't a huge deal. But from the actual systems perspective, you had a digital backup. There were a whole lot of subsystems to this in going from digital or analog to digital. Basically, during takeoff, he had a flight control malfunction. He was not able to safely control the aircraft. After correctly determining that it was unsafe to take the aircraft further, the pilot responded in accordance with emergency procedures and ejected. He was evacuated by Rescue 10 and transported to the hospital. This is how a flight control computer works. So the pilot has an input or pilot makes an input that goes to the digital flight control computer. The flight control computer takes air data sensors or information from the air data sensors. It takes information from the rate gyroscopes, which is pitch, roll, and yaw, PRY. We have lights, PRY lights, accelerometers, and angle of attack transmitter. So you've got the angle of attack probe that's given it information. With the pilot control inputs, the flight control computer processes this data with various sensors to position the flight control surfaces. Pitch rate gyroscope is a specific component that provides electronic pitch rate, including input to the flight control computer. So it's pitch rate, the rate at which the nose is pitching. Remember, the F-16 is inherently unstable. It needs the flight control computer to fly. There's no direct connection. There's no way to override it. There's ways to change the flight control laws, kind of like Airbus, but there's no way for you to just manually control. Everything is basically a vote to the flight control computer. Once it determines what it needs to do, it takes that input, goes to the movement of surfaces, and creates movement. So it decides which control surfaces need to move and then moves that. I don't know why this is done twice. It looks like the identical thing. So root cause. So here's what happened. There were degraded pitch rate gyroscopes, which form part of the motion sensors feeding inputs to the digital flight control computer. 2 out of the 4 pitch rate gyroscopes in the F-16 gave erroneous but similar inputs to the digital flight control computer. This resulted in the flight control logic accepting the similar erroneous inputs as correct and sequentially rejecting the inputs from each of the remaining gyroscopes as incorrect. Consequently, the digital flight control computer maneuvered the aircraft in response to the erroneous pitch rate feedback system signal from the 2 degraded gyroscopes, making the F-16 uncontrollable by the pilot. This is a rare occurrence and the first such failure reported since the F-16's inception in 1974. So basically, the flight control computer has redundancies, and it looks at all these sensors. It takes all this input in, and it goes, okay, what do I expect? And it compares all the different inputs, and it throws out, essentially, it ignores what it thinks is a bad input, right? Because you're not averaging, because if you got one that's way out to lunch and way off from the numbers that it's expecting, well, you might end up with this. So by design, it's supposed to ignore or throw out the bad data. In this case, that's what failed. It had two sources of input that weren't great, but those two sources were what it took because it believed that was correct, and it threw out the good data. And the next thing you know, you're in an uncontrollable situation. So the summary of events: before takeoff, they did the pre-flight built-in test, and it did not detect any faults. So that's part of flying the aircraft. As the ground operations, you do a flickus bit built-in test. And if you ever sit there and watch it, the F-18's got the same thing. All the control surfaces, it'll look like the jet's having a seizure. It kind of does the funky chicken, because what it's doing is it's going through a test and determining, number one, are the inputs good? Can it properly control each flight surface? It moves each flight surface individually, and you'll see that while it's running through it. It requires no input from the pilot other than to turn it on, make sure that it's working. You reset it and then turn on the bit, and the bit will go through its thing and let you know if it was good or bad. So in this case, it had no fault. Pitch rate gyroscopes 1, 2, and 3 provided correct and similar inputs to the digital flight control computer, while pitch rate gyroscope 4 remained as a backup. So everything was good to go on ground ops. There was no reason to abort and call maintenance. There was no indication at this point that something was wrong. At takeoff, pitch rate gyroscopes 2 and 3 were degraded and gave erroneous but similar inputs. So they were both wrong, but they were wrong the same amount. So 2 out of 3, right? 4 is a backup. 2 out of 3 were giving the wrong information, so it threw out the one good one. As input from pitch gyroscope 1 was different from the other 2, it was rejected. Pitch rate gyroscope 4 was activated, but also rejected. See, I'm not sure why that part happened, right? So I guess it's basically thinking, my 3 primaries, 2 are saying this, 1 is saying this, 1 is obviously wrong. We're going to activate 4, but we're going to reject that too. I don't know where that disconnect happened. So then you get a flight control malfunction warning triggered in the airplane. In this scenario, 2 and 3 continue to give erroneous but similar inputs. It took the inputs from 2 and 3. The aircraft was deemed uncontrollable by the pilot, because the aircraft is taking that bad data and positioning flight control surfaces in relation to that based on what the pilot's inputs are, and the pilot is responding to the real inputs. So the jet and the pilot are now disconnected, and the jet's kind of doing its own thing based on wrong information. Once you get into that situation, the jet's pitching up out of control, you got to jump out. There's no option here. The investigation concluded that maintenance happened in accordance with established protocols and adhere to all inspections. The gyroscopes are the same as those used by other F-16 operators around the world. Lockmart does not stipulate any preventative maintenance for these gyroscopes. They're to be replaced when a fault is detected, because typically 1 or 2 faults will happen, not all of them. F-16's pre-flight built-in test did not detect the fault with the functioning of the gyroscopes before takeoff. That's usually where it'll be caught. So going forward, it's assessed that the 2 pitch rate gyroscopes had degraded due to wear and tear and failed at takeoff. Worst possible time. Swiss cheese model just lined up. To reduce the chance of reoccurrence, they've put in place an additional preventative maintenance procedure for the gyroscopes, under which RSAF engineers will periodically remove the gyroscope assemblies and test them using specialized equipment. This will increase the likelihood for engineers to detect early signs of degradation and preemptively replace the gyroscopes before they reach the stage of accelerated degradation leading to failure. This measure is over and above prescribed aircraft manufacturer maintenance procedures. Before RSAF resumed F-16 flights on 21 May, they had all been checked and cleared. The IG, that's different here. In the U.S., the IG's office does not look at investigation findings. It's JAG. It's not an IG function here in the United States. So it's interesting that happens. External review panel on the safety has also been updated with the investigation findings, and it will continue to ensure the highest standards for airworthiness aircraft. So in case you're wondering what the gyroscope is, it's a mechanical spinning rotor set with gimbals to help detect rotation rates. This is then converted to electrical signal readings, which are fed to the flight control computer. It has 4 of them. 3 are in normal, and 1 is a backup. Great job to the pilot, recognizing an unrecoverable situation, getting out, and safely ejecting. I mean, we're glad that the pilot survived. You don't want to be the one that has the once in a lifetime or once in a million failures, but we did learn something. And the thing is, F-16s are aging aircraft. A lot of these jets were built 30, 40 years ago, and these parts are failing. So it's important that as we learn about these failures, that we update maintenance procedures, increase the inspections, and make sure it doesn't happen again, because now this information has been sent out to all F-16 operators, and I'm sure it's an emphasis item. It's something you're like, oh, hey, we probably should check that out. So it's not a fault. I know people are going to be like, well, why is it designed like that? Because the F-16 is an awesome fighter. And in order to get that kind of performance, the flight control computer has to be involved. It's a dynamically unstable aircraft that gets its performance based off of what the flight control computer can do. So you don't want to lose that. And most new jets are being built like that too. I mean, if you look at airliners, the 787 is pretty much the same thing. You know, it's a vote. You know, it's different flight control laws and stuff like that. So the bottom line, pilot ejected safely. We lost an F-16, but nobody on the ground was hurt. So overall, we learned some lessons and lived to fight another day. Let me know in the comments what you think. Hope you guys enjoyed this episode. Thanks for watching. See you next time.